simplifying logistics and increase in engine reliability. The first customer Jordan required China to provide a service life expectancy for all onboard subsystems. This had never been done in China before. Nevertheless, efforts were made to meet the requirement, resulting in confirmation that the service life expectancy of Chinese systems reached at least 60% of that of the original Soviet MiG-21. By November 1982, all 20 had been delivered to Jordan. These aircraft would later be transferred to Iraq. 22 were also sold to Sudan, and 90 sold to Iraq. The general designer of the F-7B is Peng Renyun. 26, 27. J-7 2 target towing jet. J-7 2 converted for target towing, with belly tank replaced by type aerial drone. For aerial drone for anti-aircraft guns or aircraft gunnery practice. 23, 25. J-7IIS, stealth research aircraft, serial #137, used to explore measures to reduce radar cross-section without changing the shape of the existing airframe. Results revealed that measures could be taken to increase stealth without altering the shape of the aircraft, but that a new airframe design would be more efficient. 28, 29. J-7-2 HUD test. A test was needed to provide side-by-side comparison of various head-up display HUD. So a J-7-2 was converted in September of 1986 to do so. HUs tested include the British Type 956 HUD rack and its license-built Chinese version designated JT-14 J-7S, larger 13 Hong Kong dollars HUDs and other HUDs for other aircraft. 28, 29. J-7IIH, upgraded J-7-2 with GJ3D general purpose MLR that can also launch PL-8S in addition to the older PL-2S and PL-5S. Since the PL-8 is 60% heavier than the PL-2, weight was added to the foresection of the fuselage to balance the change of center of gravity. Maneuverability is thus decreased slightly. A Type 941-4 decoy launcher is added, which was the first time ECM was adopted for J-7S. The general designers were Liu Yuying and Song Kaiji. When production ended in 1993, a total of 221 had been built. 30, 31. J-7H, renamed J-7IIH with redesigned rear fuselage section to withstand the higher temperature of the new engine. 30, 31. J-7HH, Planaf J-7H with magnesium alloy replaced by aluminum alloy to better withstand salinity and humidity. 30, 31. J-F-7M Air Guard Series. Bangladesh Air Force F-7MBJ-F-7M Air Guard Series has the most models within the series. Originally intended for domestic use, but that plan was cancelled after the budget was cut. The series became a major export success and received the name Air Guard. Most models of the series are equipped with British avionics, which were later on produced in China as part of a technology transfer deal. The general designer of most of these models is the same that of the J-7I and J-7-2. Due to the need to meet the urgent delivery schedule of the first customer, it was decided to take a multi-pronged approach to speed up development. Several different prototypes were developed to test different subsystems of the aircraft. Development began at the end 1978 with negotiation beginning on the 3rd of March 1979. After 10 rounds of negotiation that lasted 16 months, a deal was signed on the 30th of June 1980, which included a technology transfer. The entire J-F-7M Air Guard program took 6 years to complete. The models produced are listed below. J-7M, a pair of prototypes of the F-7M, both of which were completed before the delivery of British avionics. used to test the redesigned fuselage, landing gear system and wings of the F-7M. The outer wing pylons are modified to carry rockets or bombs in addition to 480-liter wing tanks. The prototypes were also used to evaluate the aircraft's flight characteristics. At least one unit would later be converted to a J-7MG avionics test. British avionics breathed for tests after China received the delivery from Great Britain. 2632. J-7M AAM and engine test. 2 J-7BS converted to J-7M engine and AAM testbeds to test newly designed engine and AAM launching systems of the F-7M. 2632. J-7M fuel and payload test. 2 J-7IIS converted to J-7M fuel and payload testbeds to test newly designed fuel system and payloads of the F-7M. 2632. J-7IA, originally a technology demonstrator of the J-7 with British avionics intended for domestic use, in September 1982, Tsuchida was named as general designer. When the projected was redirected to export, 33-34, it became an avionics test for the F-7M. A total of 2 were built to test British avionics. 26-32. The most distinct characteristic of this model is that it was equipped with British Type 956 Huda-Wak, and British Skyranger ranging radar in place of the original Chinese ranging radar. Other British avionics adopted were collectively known as the MAD-7 Avionics Electronic Defence System. A total of 3 were built. During testing, one of them was flown to Seoul Air Base in South Korea on August 7, 1983, by defector Sun Teum-chin. The aircraft was later returned to China after Sun was sent to Taiwan on the 24th of August of the same year. 27-33. Pakistan contributed greatly to the J-F-7M program, although Pakistan did not purchase any F-7M and later returned all 20 F-7Ms to China after evaluation, requiring China to provide a better fighter, which eventually resulted in the F-7MP and F-7P. Pakistan did provide important support for the F-7M program, after the then Vice Chief of the Air Staff of Pakistani Air Force, PAF, Air Marshal Jamal Khan inspected prototypes in test flights in July 1983 at Dalian. Pakistani contributions include in the last quarter of 1982, test flights revealed that the radar was plagued by ground clutter. China did not have any Western radar-assisted air-to-ground attack experience and had no idea how to conduct the necessary flight tests specifically designed for the Western avionics to solve the problem. Pakistani Air Force provided pilots, including F-16 pilots, to China to assist in these tests and helped in solving this problem. 35. The test assaults eventually lead to the British providing a new radar Skyranger 7M for the F-7M, which is an upgraded Skyranger radar with additional circuitry to filter ground clutter. The Chinese 630th Institute, responsible for the F-7M program, lacked the facilities and experience to conduct live fire tests with advanced Western avionics. It also lacked the capability to conduct mock air combat with Western aircraft. Therefore, from June to September of 1984, 2 F-7Ms were sent to PAF base Peshawar to conduct such tests. Pakistan Air Force, PAF, once again provided F-16 pilots to help complete the tests, with a Chinese team in Pakistan led by Chen Baoqi, of the Chinese Aviation Ministry, and Zai Angqing, of Chengdu Aircraft Company. 36. J-7M composite test. Due to the adoption of lighter Western avionics, the center of gravity of the aircraft had shifted. as an alternative approach to rebalancing the center of gravity by adding weight to the forward fuselage. Reduction of weight in the rear of fuselage by adopting composite materials was attempted. A single prototype with vertical tail built out of composite material was built for evaluation. Utilizing composite material had not only achieved the necessary weight reduction, but also greatly simplified production process and significantly increased the service life of the tail assembly. However, although the result was satisfactory when tests concluded in 1986, composite construction was not adopted for production aircraft 37, 38, due to Chinese technological bottlenecks in the 1980s. Because manufacturing of composite material at the time was extremely difficult and costly for Chinese industries. Experience gained from utilizing composite material on the J-7M would later help China to achieve greater utilization of composite material on later aircraft. F-7M, serial production version with Peng Renaying as the general designer. Due to lighter Western avionics, an additional 130 kilograms was added to the forward fuselage to balance F's center of gravity, when it was decided not to use composites. Service life of subsystems on board reached 75% of Soviet ones. Can be visually distinguished from its prototype by the absence of the VHF radio antenna atop the vertical tail that was present on the J-7IA. 60 were delivered to the Royal Jordanian Air Force, AJAF, in May 1985 and subsequently transferred to Iraq. A single unit was sold to the USAF to play the aggressor role along with 15 F-7IICs delivered earlier. Various Western avionics, later license produced in China, including SAD Smiley 26, 39, British Skyranger 7M ranging radar, original Skyranger radar upgraded with an additional circuitry to filter ground clutter. Has a parabolic antenna and weighs 41 kilograms with a range of 15 kilometers. British Type 956 Huda WAC, head-up display and weapon aiming computer. This HUD has a built-in targeting computer. Poor quality of domestic Chinese canopy interferes with the performance of HUD, so a British canopy was used. British avionics package collectively known as the MAD-7 Electronic Defence System. British Type 50-048-02 digitized air data computer. British Type 2032 gun camera, which is linked to the HUD with the capability to exchange rolls of film while airborne. Each roll of film lasts slightly over 2 minutes. An American converter that is over 30% more efficient than the original Chinese converter. American Type 0101HIA/2 radar altimeter with range increased to 1.5 km in comparison to the original 0.6 km of the Chinese radar altimeter it replaced. British AD3400 encrypted radio with a range in excess of 400 km at 1.2 km altitude. Other improvements include a new domestically designed CW1002 air data sensor developed in conjunction with the Western avionics, and the WP7B/WP7BM engine. Myanmar Air Force F-7IIK, a cheaper version of the F-7M, essentially a J-7IH with the wings of the F-7M, but domestic Chinese avionics, including some, but not all of those of the F-7M. Avionics unique to this model include Type 602 IFF Type SRT651C radio, Type GG15 integrated altimeter system, Type XJ6G sensor. 10 delivered to Myanmar in 1990. 4041. F-7BK, renamed F-7IIK with redesigned rear fuselage section to withstand the higher temperature of the new engine. 4041. 48 delivered to Myanmar by 1999. Reportedly, the 10 F-7IIK delivered earlier were subsequently updated to this standard. F-7BS, F-7BK equipped with a WP-72 batch BM Type 4 engine. Lacks a HUD, so the domestic Chinese canopy was used instead. 4 delivered to Sri Lanka in October 1991. 41. F-7IIN, export version of the F-7M for Zimbabwe. Basically a J-7 with engine, wings, fuel and weapons systems of the F-7M. Due to the tropical climate of Zimbabwe, cockpit air condition system was improved while helmet warming and dicing systems were removed along with IFF. 8 delivered to the Air Force of Zimbabwe, AFZ, in 1987. 41. F-7BN, renamed F-7IIN for AFZ after reworking the rear fuselage section to withstand the higher temperature of the new engine. 41. F-7MB, F-7M derivative for Bangladesh with WP-7IIC replacing the WP-7IIB, batch BM, engine, and LJ-2 radar warning receiver, RWR, photo reconnaissance pods can be carried on the wing pylons. The centerline pylon is modified to carry a Type 3AM aerial target in addition to the belly tank. The instrument panel was modified accordingly to operate these new systems. 14 delivered to Bangladesh Air Force, BAF, in October 1989. 28, 42. F-7N, improvement version of the F-7MB for Iran. Radio compass is replaced by AD 2780 TACAN. Metric units replaced by British units on all displays. 30 delivered to the Islamic Republic of Iran Air Force, IRIAF, in 2 batches at the end of 1990 and early 1991 respectively. 28, 42. J-7IIM, domestic Chinese version of the F-7M, with additional capability to be armed with PL-7 and PL-8 AAMs, Type 956 HUD rack modified to be compatible with these missiles. As with the J-7H, additional weight is also added in the forward section of the fuselage to correct the center of gravity, which is changed by the heavier PL-8. Deliveries started in 1986. 41. F-7MP /P Skybolt series. Pakistan did not purchase any F-7MS and later returned the 2 F-7MS to China after evaluation, requiring China to provide a better fighter, which eventually resulted in the F-7MP /P Skybolt series. The PAF does not distinguish between the two, referring to both as Skybolt. Evaluation by the PAF led to the Pakistan Air Force F-7P Overlara conclusion that with the exception of range, the F-7 Skybolt series outperforms the Dassault Mirage 5 in every aspect. 43. The number of modification requested by the PAF to the original F-7M totaled 24, making the F-7MP /P sufficiently distinct from earlier F-7s to form a series of its own. Sad smiley. 44, 45, F-7MP, development of the F-7M tailored for Pakistan. This model included 24 separate improvements over the F-7M, including using a Martin Baker Mk-10 ejection. Ceto replaced the HTY-2 on the F-7M, a Rockwell Collins AN /ARC 164 and 186 radio, and /APX 101 IFF. LJ2RW ran a more advanced oxygen supply system than that of earlier F-7M. Because the F-7MP carries more Western weaponry, the software of the Type 956 HUD rack was upgraded to include parameters for these weapons. The outer wing pylons are modified to fire AAM in addition to rockets and bombs. The F-7MP was initially equipped with the Italian Grifo 7 fire control radar license assembled by the ISO-9002 certified camera avionics, electronics and radar factory of the Pakistan Aeronautical Complex, PAC. The 55 km